Hello, students. So, as I told you in previous videos, that the most important topic in Unit 1 is backpropagation algorithm. Now, it may have happened that many topics of Unit 1 have been covered in previous subjects like AI and Introduction to Machine Learning. But backpropagation algorithm is new to you, important from your career point of view, and during interview they may give you one network and they may ask you to apply backpropagation algorithm on edge. Okay. Now, in multi-layer perceptron network, we have seen that when we are proceeding in forward direction, that is from input layer to output layer, at output layer, we will arrive some output. Okay, we will arrive on some output, but we are not satisfied with that output because there is a huge difference between the expected output and obtained output, that is a predicted output. Means there is a huge loss. Now this loss may affect the accuracy of your prediction. So how we can reduce it? To reduce that loss, the technique used is called as a back propagation. Okay. Now let us see what is our back propagation algorithm. Backpropagation algorithm is a fundamental building block of a neural network, which is mainly used to improve the accuracy of your neural network. When accuracy is improved, then only you can come to a conclusion that your neural network is properly trained. And it is based on a rule that is called as a chain rule. And this chain rule is possible because of connectivity of your neurons. As you can see in diagram that arrow is given from output layer to input layer. Now what is this? This is the input layer. As we can see in the diagram that this is input layer. Now this is what? Hidden layer, and this is the output layer. Okay. Now generally in forward pass we are proceeding from input layer to output layer. Okay, in between the hidden layers will be there, but in back propagation, based on our predicted output, again we have to come back to the input layer. That's why it is called as a back propagation. So back propagation performs a backward pass. Now what it is doing in this backward pass? Why we have to go in backward direction? Because we have arrived on a particular output using some weight and bias. So the assumed weight and bias are not as much perfect to get me a perfect output. Okay, to get me the output with less error. So what I can do, input I cannot change, but I can change the weight and bias. So that is done in the back propagation, means you have to adjust your weights and biases. Now, based on the feedback that is generated in your network, you are calculating the error and then only you are propagating in a backward direction. Okay. Now, till now, many times we have seen that this is the input that is given by your data set. You will assume weights, you will assume some bias, then there will be an activation function that is called as a transfer function, which will transfer my weighted sum and bias to the output. So in this way, I'm getting some output. So that output should be compared with the expected output and a error will be calculated. Now, what are the steps in your algorithm? Now, first, a network will be given to us in which I will have the input layer, hidden layers, and output layer. Now, user is only giving me input, how many hidden layers are expected, and what is the expected output. Only this information is given by the user. Sometimes the number of the hidden layer will not, also not be given. Only the input and expected output will be given. Now, for my weighted sum, I need weights and input. Input is given by the user. Now what I want the weights. Okay, so I will initialize my weight vector to low values. Then what I will do? I will perform a weighted sum. That weighted sum will be applied to the activation function, and this process will be repeated from hidden layer to the output layer. So now at output layer, I will arrive on some output and then I will calculate the error. That error is the difference between the expected output and the predicted output. But I don't want simple error. I want a derivative of that error. I want derivative of that error. Now, why I am going for the derivative? Because you know that because of derivation only, we can find out some slope. Now, in our gradient descent, what we are going to do? We want a local minima and global minima. Local minima means what? The low value of error for any node in a particular layer as compared to its neighboring nodes. And global minimum means what? It is the low error among all the layers of your network. So when I am trying to find out this, I may be at particular point here and here. Now, when the rightmost values are increasing, then it is a negative slope. And here rightmost values are increasing. Now it is a positive slope. So like this, the negative slope and positive slope is calculated in gradient descent, and that is possible using your derivative only. That's why the derivative of error is used. Then based on this one, the weights will be updated in reverse direction. Means you have to move from output layer to the hidden layer to the input layer. Okay. And based on the updation of weight, updation of bias, again, you will get new values for your weight and bias. And then you have to continue with your forward pass. Then again, the output will be calculated. Again, difference will be calculated. Again, back propagation will be repeated. So this is called as epoch. Means when you are moving from input layer to the output layer, that is called as a epoch. And in every epoch, you are trying to find out a gradient descent. You are trying to minimize your error. Okay, you are trying to find out the global minima of your error. And using back propagation, you are converging it. Okay, that is called as a convergence. So this is what your algorithm is. Now let us try to put it using some mathematical formulas. Consider D as your data set, which is containing the input. L is the learning rate, and you are having a network that is a multi-layer feed-forward network, means which is containing the input layer, hidden layers, and output layer. Then at the end, you will get a trained neuron network. Now, why I'm using the trained word is because my error is low. And when error is low means what? It is giving me perfect accuracy. Okay. Now, these are the main steps of your algorithm. Now, I will initialize a weight and bias. Input is already given by the user. Now, what I will do is till my terminating condition is not satisfied, means till my error is not low. What I will do for each training tuple X in D, for each input layer, I will calculate the output. Now, how I will calculate this output? How I will calculate this output is using the activation function. Now, what I am doing, I am applying some weighted sum into your input plus theta. Theta is what your bias, and then you will get some ij. Okay. Then what is the activation function I'm using here? 1 divided by 1 plus e raised to minus x. What is this? Which activation function? Yes, sigmoid activation function. And I will get my output. Now remember the term OJ. What is OJ? Predicted output. Now you have to calculate the derivative of error. To calculate the derivative of error, it may exist in your final output layer or it may be in between your hidden layers. Means error may occur in your output layer or it may occur in between your hidden layers. So there is a different formula to calculate this error at the output layer and hidden layers. For output layer, just you have to find out your predicted output 1 minus O and T minus O. Now what is T? That is the expected output. So this formula you are using in which layer? Output layer. Now for hidden layer, what you have to do? O 1 minus O is as it is. And summation of this error with the weight. Means at hidden layer there will be the weights na, for those connections. Then those all sum you have to take. Now based on this um, error at your hidden layer, then again multiply it with the output at that particular layer, multiply it with the L, that is the learning rate, you will get delta. That is the updation that you have to do in your weight. So weight should be updated. Then how to update the bias? The learning rate will be simply multiplied with the error. Then that will be the bias increment. So based on that small value, again increment your bias. Now, due to this weight updation and bias updation, what has happened? You have got the new value for your weights and bias. Now, again using these new values, repeat the process from starting and calculate the error. If that error is in satisfied range, okay, you can stop at that point. Again, we have to backpropagate if that error is not in the satisfied range. So again, you have to converge your network. Okay, so this is what the whole backpropagation algorithm. So in upcoming video, we will apply this backpropagation algorithm on one network. At that time, what is your task? Remember these steps. Okay, means weighted sum plus bias, apply it to the activation function, get the predicted output, and how you have to calculate the error at output layer, at hidden layer. Remember this formulas. Then how you are updating the weight, multiply that error with the output and learning rate, but multiply the learning rate and error, you will get the update in bias. And these two updates you are going to use to perform the forward pass again, unless and until your error is in expected range. Okay, unless and until you will not say that your network is trained. Now, why we are using this backpropagation? It is fast, simple, and easy. Now, you may say that, is it easy? Yes, it is easy if you have practiced it on more and more examples. Okay. Now, once the input has arrived, you will not ask anything from user. Means there will be no output that will affect you. Okay. No external parameter that will tune your network. Only the input is important. Okay. But how many inputs are there, that will also not affect to your network. And you can apply it without the prior knowledge of your network. Means you can easily repeat your echoes. Okay. And it works well. And there is not special feature that you have to learn for this backpropagation algorithm. Means if you know the simple mathematics, you can apply it. So this was all about the backpropagation algorithm. So as I told you, in upcoming video, I will apply backpropagation algorithm on one example. Thank you.